So welcome back, NCEA Level 2 physicists, continuing on with nuclear physics, today looking at radiation. So in order to understand radiation, you have to understand a little bit about the atom and notations used in atomic physics. Okay, so in terms of writing atoms, we have both the mass number, which is the top number, the A, which is the number of protons and neutrons in the atom's nucleus, and Z number, which is the atomic number, which is the number of protons in the atom's nucleus. You're also going to be able to differentiate between isotopes and nuclides. Okay, so isotopes, so carbon 12 here and carbon 14 are example of isotopes because they have the same number of protons, because every atom of carbon has 6 protons, but they have a different number of neutrons, hence they have a different mass number. Okay, that's the example of isotopes of carbon. And individually, they're known as nuclides. Okay, that's the single atom configuration. So you have a carbon 12 nuclide and a carbon 14 nuclide. So for example, in terms of reading isotope symbols, the mass number here for sodium is going to be 23. The atomic number is going to be 11, number of protons. Therefore, number of protons will also be 11. And we'll get the number of neutrons in the sodium nuclide by subtracting 11 from 23, which gives you, of course, 12 neutrons. For the oxygen nuclide we have here, mass number is 15, atomic number is 8. Number of protons, therefore, is also 8. And the number of neutrons is 15 minus 8, or 7 neutrons. And in terms of isotopes, the mass number for this particular isotope is 19. That goes at the top. The atomic number is 9. Every fluorine atom has 9 protons. Therefore, the number of protons is 9, and the number of neutrons is 19 minus 9, or 10 neutrons. Magnesium, the mass number is going to be the sum of the protons and neutrons, so 12 plus 13, or 25. The atomic number of protons, which is 12, and that's how you would do that nomenclature. So in terms of the fundamental forces involved in the atom, the strongest force is the nuclear force. It is very short range. It's basically between protons and neutrons in the nucleus, and between protons and protons in the nucleus, and neutrons in the nucleus. But it is also the strongest force known in the universe. We then have the electromagnetic force, which is going to be your force between the electrons orbiting the nucleus and the positive nucleus with the protons. Then we have the gravitational force, and finally the weak nuclear force, which is the weakest of all the forces. So basically, the reason why we get radiation is because nuclei want to become stable. And the way they do that is by ejecting particles, which we'll look at later. So if you've got too many protons, for example, the nucleus will emit protons in order to get to a stable configuration of neutrons and protons. Because remember that protons are positive, okay, so they're going to repel each other, and the neutrons are going to hopefully separate the protons sufficiently to maintain the stability in the nucleus. Okay, so that's why we get instability. Basically, nuclei eject particles until they become stable. That's what that graph also represents. So reactivity, by definition, therefore, is the process in which the unstable elements decay or break down into new elements, and they release energy as particles and or waves. And they usually do that as a combination, and we'll look at that in more detail soon. Okay, and where does radiation come from? Primarily, the background radiation, which is measured in sieverts, essentially comes from natural sources. And the most common one is radon gas, which is a isotope of radon, which is part of the stability process of as uranium tends to decay, and it's quite common in caves, for example. Okay, so you've got, basically you can see that's the most. So the idea of nuclear fallout's quite small, medical radiation is quite small, but the majority is in the form of your radon gas, about 55% of background radiation. And is radiation dangerous? Well, you can see from the infographic that definitely it can be. Okay, so if you get about 10,000 microsieverts, that'll kill you within a couple of weeks, and a simple dental x-ray will be about 0.01 sievert. So there's a whole range of medical conditions as the amount of radiation exposure increases, and that is radiation.